Students, I hope you are fine. This is our lecture 6. In this lecture, we are going to, our subject is soil texture. Okay. Now let us look at the definition of soil texture. What is soil texture? Soil texture is nothing but the relative proportion of soil particles or soil separates, and these particles are sand, silt, and clay in the soil, and they are part of soils. Okay. Soil texture is a basic property of soil, and this basic property, it is hard to alter or to change. Okay. Now, soil texture is made up of three you know three soil particles, and these soil particles are sand, silt, and clay. These soil particles are differentiated amongst each other in terms of their size. For example, the United States Department of Agriculture, that is the United States Department, that is the USDA, classifies sand particles as particles that range in size from 0.05 to 2 millimeters, and silt are particles that range in size from 0.002 millimeters to 0.05 millimeters. And the clay are the smallest particles, which are less than 0.002 millimeters in size. Okay. Now, this table shows at the top the different soil particles, which are sand, silt, and clay, and on your left hand side these particles shows us the physical properties of these soil particles. We have our particle sizes, and we have the feel. So how do these soil particles feel in your hand, right? Well, the pore size, the pore spaces between these soil particles, water and nutrient holding capacity, specific surface area. So if we are looking at sand, for example, we know sand from the previous table that the size of the sand particles ranges from 0.05 to 2 millimeters. And when you feel the sand will feel gritty, okay, just like the table salt, okay. And the pore sizes of the sand particles are large, okay. The water holding capacity of sand and the nutrient holding capacity of sand is very small, is less. The ability to hold water and nutrient is very less. And therefore, and lastly, the specific surface area of sand is very low. So if we jump silt and go to the clay soil particle, clay particles, we've said that these are the particles that are less than 0.002 millimeters in size, okay. And these clay particles, when they are wet in your hand, they will feel sticky, okay, like moist putty, and the pore size of clays is very small, is little, because clay particles are very tiny, they are very small, and the water and nutrient holding capacity of clay is very large, is very high. But these, in other words, water and nutrients are released by clays, are released by clays like in very small amounts. And the specific surface area of these clays is very large, that is why I said the tremendous is very huge, okay. And the properties of silt is between the sand and the clay, okay. For example, the specific surface area for For sand we said it is low, whereas for silt is large, and for clays is very, very large, it's tremendous. Okay, and the water holding capacity and nutrient holding capacity for sand is less, for silt is more than sand. Okay, but less than clays. Then for clays is high. Okay, now if we look at this table again, this table on your x-axis, on your y-axis, it shows us the specific surface area in square millimeters per grams, and on the x-axis it shows us the particle sizes, and our particles, the smallest, we said our smallest particles are clays, followed by silt, followed by sand, and here in this, in this figure, they included gravel, which is larger than sand. Okay. Now, in other words, the particle size increases from the x-axis, increases from the left-hand side towards the right-hand side. Okay, and the specific surface area on your y-axis, on your y-axis increases as you go up. As you go up the y-axis. Okay. Now this line, this red dotted line, is an exponential size. It is an exponential, line, and it is a negative exponential. In other words, when the surface area, when the specific surface area decreases, the particle size increases. So in other words, specific surface area decreases with an increase in particle size. Okay. So again, if you look at this tube, if you cut this tube into smaller pieces, you will get something like this. You'll get something like this, and the specific surface area, because you have divided this this tube into smaller segments, therefore the specific surface area of this is larger than this tube. Okay, and because specific surface area is related to adsorption, swelling, plasticity, and heat of wetting. So sand particles have less adsorption capacity, less swelling, less plasticity, less heat of wetting than the silt and the clay. Okay. If we look at specific surface area in detail again, the small particles, and in this case are the clay particles, have high or more specific surface area. Okay, and because the clay particles have more specific surface area, they have high ability to hold water. Okay, and small particles again have small specific surface area, and they have more ability to hold nutrients. Okay, and we have small specific surface area means that more area for weathering. Right, and more area for weathering means more nutrients will be released by weathering. More specific surface area means more ions in surfaces, in other words, in the surfaces of those columns. Okay, and this means that the more the soil sticks together as aggregates, and the more specific surface area means that the more chances of microbial activity. Okay, now So if we look at soil textural classes, soil textural classes convey an idea of size distribution of particles and the general nature of their physical properties. And soil textural classes are depicted by using a textural triangle, and I will show you a sample of soil textural triangle later on in this lecture. And the soil textural triangle has 12 textural classes. Okay. Now this is an example of a soil textural triangle. It has these classes, soil textural classes. The first one is our clay. The second one is silty clay. The third one is sandy clay. The fourth one, clay loam. 5, silty clay loam. 6, sandy clay loam. No, 7, silt. 8, silty loam. 9, loam. 10, sandy loam. 11, loamy sand, and 12, sand. Okay. Now, on your left hand side, in this area, this area is the percentage what is the percentage clay. Okay, and the percentage clay increases from 0 to 100% when you go diagonally up towards your right hand side. And on your right hand side in this soil textural triangle, the right hand side shows you the percentage silt, and the percentage silt increases from from the top to the bottom. In other words, when you are going toward when you are going downwards, the percentage silt increases 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. This 30% indicates that 30 in this area, in this region, there's the silt content is 30%. Okay, and at the bottom there, the bottom shows you the percentage sand, and the percentage sand increases from right to left. Okay, now if we look at this table shows you the general terms used to describe soil texture in relation to basic soil textural classes. Okay, so these are the basic soil textural names: sand, loamy sand, and these are the ones that we found from the soil textural triangle. Okay, there are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if we look at this general texture terms, you know, sands and loamy sands are said to be coarse. Okay, whereas sandy loam, fine sandy loam, very fine sandy loam, sorry, sandy loam, fine sandy loam are said to be moderately coarse, obviously. Then very fine sand, sandy loam, loam, silty loam, and silt are said to be medium. And sandy clay loam, silty clay loam, and clay loam are said to be moderately fine. Sandy clay, silty clay, and clay are said to be fine, obviously. And the fine soils are said to be the fine texture soils are said to be clay soils. Okay. And moderately fine soils and medium textured soils and moderately coarse soils are said to be loamy soils. Coarse textured soils are said to be sandy soils. Sorry. Now let us look at an example. How to use soil textural triangle. This is this part you must this part is in your exam. Please understand. Now this is an example, right? Mr. and Ms. Madolo has just found out that their soil estimated percentage clay, percentage silt, and percentage sand are 30, 20, and 50 respectively. In other words, the percentage of clay is 30%, the percentage of silt is 20%, and the percentage of sand is what to call it, 50%. What is the soil texture class of Mr. and Mrs. Madolo? So let's go to an example. So the example says that their soil percentage clay is 30%. So what you are going to do, we are going to draw a line from this 30% percentage clay across the soil textural triangle, and you will draw this line using a pencil. Now the second thing that we have to do for silt, they said that the example said that their soil contains 20% silt. So from this 20% silt, this is 10% silt, this is 20% silt, and this is 30% silt. Now they said that Miss and Mr. Madolo's soil has 20% silt. So from this 20%, you will draw a line diagonally downwards towards your left hand side. Okay, straight using a ruler and a lead pencil. Now from this again, their soil has 50% sand. What you are going to do, you are going to grow from this is at the bottom there, the soil textural triangle shows the percentage sand. This 10 indicates 10%, 10%, 10% sand, 20% sand, 30% sand, 40% sand, and 50% sand. So what we are going to do, the example said that Mr. and Mrs. Madolo's soil contains 50% sand. Okay, so what we are going to do, you are going to draw a line from the bottom, from this 50%, diagonally upwards towards your left hand side, okay. And now this area where these three lines meet, that is your soil textural class. And in this case, our soil texture, our lines meet at the sandy clay loam soil textural class. Because this dot is situated within this area. This area indicates the sandy clay loam. Okay, makes sense. Now, another method to determine soil texture is to determine soil texture by feel method. Remember, we did a practical on this one, so I won't talk much. I won't explain much on this one. But usually in this method of determining soil texture, what you have to do, you have to follow this soil texture chart, soil texture chart. Okay, the soil texture chart will give you directions. It will tell you that place about 25 grams of of a soil sample in your palm. Then you will moisten that soil, and you will form a ribbon. After forming a ribbon, you will place your soil sample between your forefinger and the thumb, and you will try to make a ribbon. Now, if the ribbon breaks before it reaches a length of 2.5 centimeters, then it means that your soil textural class is your soil is loam, is loamy soil. And if your ribbon length is between 2.5 and 5 centimeters, then your ribbon is clay loam. And if the ribbon is greater than or equal to 5 centimeters, then the ribbon is, your ribbon, your soil is clay soil. Okay. Now this is a picture of a person holding a soil as a sandy soil. Now sandy soils are non-cohesive. In other words, they do not stick together unless they are wet. As you can see, this is a moist, sandy soil. So it will stick together if it is moist. However, if the if the sandy soils are dry, they won't stick together. That is why I said the sand is non-cohesive. Okay. Silt. This is a picture of a person holding a silty soil. Silt does not feel gritty like sand. It is flowery and it is smooth like silky part. Okay. And the clays on wet is very sticky and is plastic, or it can be molded readily into a shape or a rod and easily formed into long ribbons. Okay. Now let us look at the laboratory methods of determining soil texture. There are basically two methods. The first one is the classical sedimentation method. The second one is laser diffraction method. Okay. Now, this classical sedimentation method, in this method, right, soils are dispersed using chemical agents and allowed to sediment. This chemical agent is sodium hexametaphosphate or chalcone, and in this method the large particles will fall first, followed by the smaller particles, and the smallest particles, which are clays, will settle last. For example, if we look at this diagram, okay, this diagram shows us a cylinder. This is a cylinder. So a soil sample was discarded or was inserted in this cylinder. This cylinder contained a suspension, right? So the coarse sand, the large sand particles will settle first, and the large sand particles will be followed by the fine sand particles, and the silt particles will follow the fine sand particles. Okay. If you look at this, this figure, the clay particles are still mixed with the suspension. This means that clay particles, they take long time to settle. Okay. They usually take 2 hours to settle. Okay. Now another method is laser diffraction method. This method is very, very, accurate and fast. However, it greatly underestimates clay, clay. And this is an example of a laser diffraction. Now, let us look at this Stokes law. The classical sedimentation method follows this Stokes law. Okay. Stokes law says that V equals to H divided by T, which is equal to D to the power 2 multiplied by G open parenthesis dx minus D sub T close parenthesis divided by 18n. Now G is the gravitational force, which is 9.81 newtons per kilogram. This G is 9.81. Then the viscosity symbol indicates the viscosity of water, which is at 20 degrees Celsius, which is 0.001. Added the this ds indicate the density of the solid particles, and for most soils, most soils are made up of quartz, and quartz, the density of quartz particles is 2.65 times 10 to the power minus 3, or 2650, and the dt is the density of the fluid, water, and the density of water is 1000 kgs per cubic meter. Now, if we substitute these values 9.81, and this viscosity of water, and this 2.65 times 10 to the power 3, and this 1.0 times 10 to the power 3, in this equation we'll get this. And if we simplify this, now we'll get this k equals to 9 times 10 to the power p divided by centimeters. Now, why are we learning about soil texture? Soil texture determines the water holding capacity of the soil. Soil texture also impacts the soil aeration. Well-grained soils allows good aeration. Soil texture also affects the degree to which the soil is susceptible to erosion, and soil texture also affects the organic matter levels of the soil. So guys, you would be unable to ask questions, but what we can do, you can ask questions in our WhatsApp group, or if you are not comfortable in asking questions in our WhatsApp group, you can ask your questions directly to me. Okay, so again, this large particle is the sand particle, which is 2 to 0.05 millimeters in diameter, and this within this particle is the silt particle, which is 0.05 to 0.02 millimeters in diameter, and the clay is less than 0.02 millimeters in diameter. So I hope, guys, you have learned something new, and I hope you are studying in your respective places, and please stay safe, and we'll meet in another lecture. That's it for today, and enjoy your day.